Hello, and welcome to my first presentation assignment for the course Engineering Electromagnetics. Frankly speaking, I don't want this to be boring, so let's start with some fresh stuff. Some fresh vegetables and some fresh food, along with noodles. But wait, did you notice that this stove doesn't use flame? Maybe it has some electric heat element inside of it, along with some smart controls over here. Wait, can you see this? The water is boiling, but still nothing is happening to this person's hand, or even this piece of newspaper. I mean, how is that even possible? Now look at this egg. The portion of egg that is lying on the cookware is cooked, but the other half is still uncooked, even if it's on the stove. So that means this is not an electric heat element based stove at all. It is something else. Is that magic? You might be wondering how is that possible? Yeah, it's written right over there. It's the magic of induction. So let me formally announce the topic of my presentation, that is induction cooktops. So, the first question, why induction cooking over the traditional cooking? The principle of cooking food in a pot or pan on top of a hot surface hasn't changed much since the dawn of cooking. With the cookware acting as the go between for the heat source and the food, its main weakness is that the heat source, be it open fire or an electric stove, only directly heats the part of the cookware that touches it. The rest of the cookware is warmed by the heat conduction, and as a result the food receives different amount of heats from different part of the pot or pan. This is why we have to stir some food constantly to keep them from burning in the pan. Induction cooktops, on the other hand, transform the cooking utensil into the heat source, thus dismissing the need for external heat source. They also have precise time and temperature control settings for better cooking experience. They are even faster than the normal stoves. And an induction cooktop is able to do all this because of electric and magnetic fields. But how? Using the power of the electromagnetic force. It's the force that forms the basis of all other fundamental forces of nature. It is much more stronger than the gravity. The suspension of magnetic levitation train above its track is a striking example of the same. As the name suggests, electricity and magnetism are very closely linked. This relationship allows them to affect each other without contact. One such way of their interaction is through electromagnetic induction. Electromagnetic induction is the principle behind that makes electric motors, generators and transformers and our induction cooktop possible. But what is actually electromagnetic induction? Michael Faraday in 1831 discovered the law of electromagnetic induction. In simple words, the principle can be described as follows. The alternating magnetic field gives rise to inductive current or to alternating electric field. As a consequence of Ampere's law and Faraday's law, a circuit with an alternating current flowing through it generates current in another circuit placed in its vicinity. So that means a changing electric current is surrounded by an associated changing magnetic field, which in turn generates a changing electric current in a conductor placed within it. Thus, in this case, placing a conductor in the magnetic field surrounding the first current generates the second current, and that's the principle behind the working of induction cooktop. So, how does a induction cooktop work? In a brief glimpse, we can say that there are coils just beneath the glass ceramic cooktop. These coils carry an alternating current, which create a magnetic field and eventually varying magnetic flux. When electric-rich magnetic cookware or ferromagnetic cookware is placed in that field, it acts as a second conductor and a current is induced on it, which is used to cook food. Mm, but now we have just generated the current. How to convert that into heat? So here's the answer. When a ferromagnetic pot or pan is placed on an induction cooktop's cooking element, a small current is induced on the cookware's bottom surface. The current has an associated magnetic field, which induces small electric currents called eddy currents inside the cookware. These currents generate their own magnetic fields. The result is lot of swirling, churning, pushing and pulling of molecules within the material of the cookware. In order to make this movement useful for cooking, it must be converted into heat, and that happens through the resistance of the ferromagnetic material. When a current is run through a material with a high resistance, much of its current is converted into heat. Thus, most of the heat used to cook food on an induction cooktop come from the electrical resistance of the cookware. So, this is a very intelligent way of cooking stuff, but it has its own pros and cons. So, let's talk about the advantages of induction cooking over traditional cooking. Ordinary gas and electric stoves use heat less efficiently. When we cook with a gas stove or an electric cooker, only 30 to 60% of heat is directed at heating up the cookware. All the rest is wasted up at heating the air in the kitchen. On the other hand, the induction cooktop heats only the bottom of the cookware, and that is why it has nearly 85% efficiency. The glass cooktop itself is heated up only due to the contact with the bottom of the cooking vessel. That is why it never becomes very hot. The reason why the paper didn't burn and why the man was able to put his hand so comfortably on the cooktop. So, along with these pros, it is also safer, faster, far more accurate method of cooking. It is more energy efficient. It is easy to clean and manage because because the top surface is gets hot very little time, very less. So, disadvantage of induction cooking. Induction stoves are very expensive if one wants something that has good quality and long life. Induction stoves need special cookware. In theory, any cooking vessel with ferromagnetic bottom will work with such stoves. However, a lot of seemingly suitable pans have a very thin bottom. The best option is a cookware with a thick magnetic bottom. Glass, ceramic, or aluminum cookware is unsuitable for induction cooktops, and that's why when we start with induction cooking, we have to buy a lot of stuff. Most induction cooktops should not be placed over other appliances which have metal elements. This can lead to a lot of problems. So, are there any health risks too associated with it? Induction stoves are safe. The magnetic fields created by them is not so strong. It works so that it hardly penetrates into the bottom of the cookware. The magnetic field does not affect the food by any means. The food is heated up by the hot bottom of the cookware. Nonetheless, though the induction stove have passed all the safety tests, some people are still afraid of the radiation hazards associated with it. Induction cooktops produce extremely low frequency radiation similar to microwave radio frequency. According to a research, this type of radiation diminishes to nothing at a distance of few inches to about a foot from the source. But some studies have been done to determine the safety of induction cooking for those who have pacemakers or defibrillators. An article at one of the government site reports pacemakers do not cause induction cooking unit interference. Another report published in Europace notes that problem may arise with an implanted pacemaker if it is unipolar and left-sided and the person is standing close to the cooktop where a pan is not placed concentrically over the coil. So that was all of it, and now the sources which I used to make my presentation are listed in this bibliography, and also the sources of image are shown in this slide. Thank you.